This is a gate problem from the bipolar junction transistors, and it appeared in the 2011 gate paper for electrical engineering. But patterns of questions like so are very common to instrumentation as well as the EC papers. So here is the problem. The transistor circuit shown below uses a silicon transistor with VBE equal to 0.7 volt and IC approximately equal to IE. The value of V0 is, assume that the DC current gain beta is equal to 100, and the options are 4.65 volt, 5 volt, 6.3 volt and 7.23 volts. So this is a typical DC bias circuit, and the way to go forward with solving these sort of questions is, number one, with this 100 ohms right here, we can convert it into kilo ohms form, and so this becomes 0.1 kilo ohm. So all the resistances in this circuit are in kilo ohms, and therefore the current will come out to be in milliamperes. Secondly, we know that according to this information, IC and IE are approximately equal. So even though they have mentioned the value of beta, as a first-hand approximation, what we can do is we can make IC is equal to IE is equal to beta times IB. So note that this is something different from what we used to know, with the fact that IC being equal to beta IB and IE being equal to beta plus 1 times IB. But here, because of this similarity equation, so we can make both of them equal to beta times IB. Next, we are interested in finding out this voltage V0, and so because this resistance is known to us, this is 0.1 kilo ohm. If we can find out this current, which is the emitter current, then we can multiply the emitter current with the 0.1 kilo ohm resistance, and we can easily find out the value of V0. Now, emitter current is equal to beta times IB, and so because beta is equal to 100, so IE is equal to 100 times IB. And if we look at this loop, so starting from this 10 volt source, if we go through this 10 kilo ohm resistance, and then there is the base to emitter drop of 0.7 volt followed by this drop of V0 volt, the only unknown from this entire loop is the value of IB. So we can use this loop and frame our KVL equation. So the KVL equation can be formulated as, this 10 volt must equal to the summation of the drop across this 10 kilo ohm resistance plus this base to emitter voltage drop plus the drop across this 0.1 kilo ohm resistance. And so we can formulate the expression like so. So 10 volt should be equal to 10 multiplied by IB plus 0.7 plus 100 times IB multiplied by 0.1 kilo ohm. And from here, from this expression, we can easily find out the value of IB, which is the only unknown, and this is equal to 0.465 milliamperes. Therefore, V0, which is this voltage drop, voltage at the emitter terminal with respect to ground, and this is incidentally the same as the emitter voltage. So this is equal to 100 times IB multiplied by this resistance. This comes from Ohm's law. Therefore, V0 is equal to 100 times IB multiplied by 0.1 kilo ohms. And we have found out the value of IB as 0.465 milliampere. So if we substitute this value over here, then the output voltage turns out to be 4.65 volt. So according to the question given here, Option A is the correct choice. So this is one of the simplest biasing circuits for BJT. There are a lot of other biasing circuits and topologies also available for bipolar junction transistor, and the same is also replicable to the metal oxide semiconductor field effect transistors. So in our later classes, we will look at how to solve questions related to biasing circuits for both BJT as well as MOSFETs.